you all for joining our webinar today on advantages of using high-resolution mass spec screening and quantification in single run for food analysis. My name is Nancy Wright-Ross, and I will be your host. If you should have any technical difficulties during the presentation, please use your chat box and let me know. Also, be sure to download the handouts. We have 5 handouts that are specific to this webinar. At the end of the presentation, we'll also have time for a brief question and answer session. We ask that you use the question box located in the drop-down panel during this time. If we are unable to get to your question, you can contact our speaker offline. I would now like to introduce our presenter for this webinar, Dr. Artem Filipenko. He's National Applied Markets Manager for Bruker Deltonics. Dr. Filipenko has been with Bruker for over 10 years and has over 15 years of industry experience in development of innovative methods and instrumentation for various analytical applications, including industrial, environmental, food, safety, and homeland security. His area of professional expertise ranges from gamma spectroscopy and neutron detection to ion mobility and mass spectrometry. I will now hand over the presentation to Dr. Filipenko.
Hello, everybody, and thank you for joining us for this webinar. The topic of today's presentation, as Nancy already mentioned, is advantages of using high-resolution mass spectrometry for screening and quantitation in food analysis. Screening and quantitation of target compounds is, of course, a typical application for mass spectrometry in food testing. Depending on specific case, these target analytes may be pesticides, mycotoxins, pharmaceuticals, or other residues in food, animal feed, water, beverages, etc. The key questions are always the same, though. We have to identify and confirm the presence of target compounds, and if we find something, we would like to know how much. Obviously, we want our answers to be bulletproof, with no false positives and no false negatives, even in complex sample matrices. And on top of that, we want the whole workflow to be fast and simple. However, food testing does have its challenges, of course. The number of regulated chemicals is increasing and databases grow with them. It may result in higher false positive rates. Requirements for throughput grow up, and driving the need for shorter LC gradients, which may lead to interferences from some of the collagen compounds. And of course, complex matrices and matrix effects make it difficult to reliably detect and quantify some of these target analytes. Plus, there is a possibility of degradation for some of the less stable compounds even before the analysis. Although triple quadruple instruments are proven and, of course, well-trusted solutions, they cannot always keep up with these challenges. However, high-resolution accurate mass instruments can. QTOF solutions have several important advantages that really make them stand out in these applications. Namely, the unlimited number of compounds to run means high productivity and flexibility. High full scan sensitivity means wide scope of analysis with low false negative rates. High specificity of accurate mass means much reduces the false positive rates. Fragment and isotope information leads to higher specificity of analysis. Retrospective data analysis capability is very important and provides flexibility for detailed data mining. And of course, capability to screen for suspects such as mycotoxins, veterinary drugs, chemical degradation products, etc., is also a very important advantage. And this is really where Bruker's TargetScreener Solution comes in. It is an LC QTOF system that handles identification, confirmation, and quantitation in a single run. It comes with a database that includes over 3,000 analytes, more than 900 of which are pesticides. And furthermore, it supports both targeted and non-targeted workflow. It means that it's much more future-proof than typical triple-quad instruments. By using standardized methods, standard column and instrument configuration, And a highly curated database, it provides a reliable screening solution with minimal false positive and false negative rates. TargetScreener is really a complete out-of-the-box solution. It's designed this way. So it is built around a solid Bruker QTOF platform that runs in both positive and negative I modes with almost no in-source fragmentation. The system includes Bruker Elute HPLC with column and method optimized to run multi-step 15-minute gradient. In the core of this solution is a software package called TASQ that is used for data processing, screening, and quantitation, and we'll be discussing it in detail. Included compound database contains information on retention time, accurate mass diagnostic kinds, adducts, and choice-topic patterns. And of course, report templates for identification, confirmation, and quantitation are provided as well. Last year, Bruker released a new version of the TargetScreener solution. Now it's on revision 4.0. One of the important additions is this new version is the support of GC-APCI configuration. APCI, or atmospheric pressure chemical ionization, is a very soft ionization technique that preserves the molecular structure of the ions, allowing for easy identification of unknowns. Now, TargetScreener can be used interchangeably with either LC or GC methods. Both modes of operation are fully integrated into the software, and switching between LC and GC takes approximately 20 minutes. Most of that time is used for thermostabilization of the ovens and transfer lines. It also means that you do not need to have dedicated MS instruments to run LC and GC methods in your lab. You can just switch one QTOF between the two modes. And of course, this kit includes everything that is needed to run the system in such configuration. TargetScreener 4.0 also expanded the supplied database. Now it includes over 900 pesticides, over 200 veterinary drugs, over 300 environmental compounds, and more than 300 pesticides and environmental compounds that have been added to a dedicated GC-APCI database. In terms of the sample extraction, catchers is the most typically used method and recommended for use with TargetScreener as well. As you probably already know, catchers stands for quick, easy, cheap, effective, rugged, and safe. All the good things. The same extract produced by catchers can be used for both LC-MS and GC-MS analysis, which really makes it very convenient. And of course, other liquid extractions or solid phase extractions that you might prefer can be used with this system as well. The TargetScreener solution is built on the Bruker QTOF technology. On the right here, you can see 3 different instrument models that can be used with TargetScreener solution. From left to right, it's Compact, Impact 2, and Maxis 2. These instruments share the same platform, but a different resolution and somewhat in mass accuracy. So Compact provides resolution of 30,000, 60,000 for Impact 2, and 80,000 for Maxis 2. Now let's review some of the QTOF principles of operation and what makes Bruker technology different from the rest. On the left is a view of the inner workings of Impact 2 QTOF instrument. Ion source is easily interchangeable, as I mentioned, either ESI for LC workflows or atmospheric pressure chemical ionization for GC workflows. Next after the ion source is an ion transfer section, a quadrupole for isolation of the parent ions, and a collision chamber for fragmentation. After it is a fly tube with dual-stage reflectron, where high-resolution ion separation takes place. And finally, the ion detector, of course. The basic principle of operation is following. Analytes from either HPLC or GC are injected into the ion source and ionized. Then ions are introduced into the vacuum through ion funnels, guided through isolation quadrupole and collision chamber. Injected into the reflection fly tube, where they separate by their mass to charge ratio based on the time it takes them to fly up and down the path. And finally detected, giving us the mass spectrum. really nothing too complicated. Now, why exactly high resolution and accurate math are important? Why they represent an advantage? Well, let's take a look on some real-life examples. So this is chromatogram for a fungicide in a real-life matrix. So we can see many peaks and do not know which one of them is our target. However, we do know the nominal mass of this fungicide. Let's say it's 343 Daltons, and can extract its iron chromatogram. With a resolution of 0.1 Dalton, it will look something like this. So this is what you get with typical quadrupole mass spectrometer, and you still don't know which peak is your target. So let's increase the resolution to 10 millidaltons and extract another chromatogram for this fungicide. Now we get 2 peaks. It's better, but we still cannot be certain. So let's increase the resolution further to 1 millidalton. And now we're in real high resolution accurate mass domain. Finally, we get a single peak and can say with certainty that this is our target. This is, of course, obviously an important advantage of high resolution accurate mass, but not the only one. When running the TargetScreener method, Bruker QTOF performs 2 different experiments on each analytical cycle that repeats few times per second. In the first experiment, instrument collects a full spectrum of all principal or parent ions, something like so. So no ion isolation, no high energy ion collisions, and no fragmentation, just a full scan of all parent ions. In the second experiment that follows, the system accelerates all ions in a collision cell and performs so-called broadband collision-induced dissociation, or broadband CID. No ion isolation takes place, and all ions are fragmented indiscriminately. It means that the system collects information on all fragment ions all the time. Both measurements are done in quarter of a second, which means that with frequency of 4 Hz, system collects both full mass range parent ion scan and full broadband CID scan. It's more than enough to keep up with modern UHPLC, and of course, abundance of the generated fragment ions provides a rich source of so-called diagnostic ions. The diagnostic ions are used for confident identification and confirmation of the target analytes. And obviously, more criteria you have to check, more accurate identification you can expect. The TargetScreener relies on a database for Analyte identification. And we prefer to call it database, not a library, because it contains a lot more information about analytes than a typical library would. For each target compound, the database obviously contains its name, its molecular formula, and retention time. Further, it includes the accurate mass of the principal ion for identification, and several, and it's important, several diagnostic ions for verification. The diagnostic ions typically include alternative ionization patterns, isotopes, and fragments from broadband CID. Each ion has a label that tells the system if it's a parent or principal or fragment ion, meaning in which spectrum to look for it. Not all ions may be required for accurate identification at all times, thus there is a flag for each one, mandatory for identification or not. Finally, there is a quantification flag that tells the system which of the ions is to be used for quantitation experiments. Different ions can be selected for quantitation in case of any interferences, and we will see some examples of that later on. It may look a bit complicated, but there is a reason for it. So let's take a look at some real-life examples. First, a really simple one. So here we have a mixture of 2 pesticides. They have the same molecular formula, same accurate mass, but different retention time. And of course, based on this difference, these pesticides can be differentiated right away, and there is no problem at all. Now, slightly more challenging example. So here we have another pair of pesticides. Again, both have the same molecular formula, same ionization pattern through protonation, and similar retention time, maybe a little bit too close for comfort. But note that different fragmentation patterns in broadband CID produce unique diagnostic ions that allow us to distinguish them very reliably. Now we want more challenging example. So 3 pesticides in one mixture, all 3 have the same exact mass. In the extracted ion chromatogram, we see 4 peaks for 3 pesticides, and that doesn't look right, obviously. So let's extract mass spectra for each one of these peaks. We'll get something like this. The first one doesn't have the expected chlorine isotopic pattern, and we know that chlorine should be there because it's part of the molecular formula for the pesticides we're looking for. So that's not the right one. This is totally different compound. Actually, it turns out to be a fungicide that just happens to have the same exact mass and present in the same mixture. The last peak we can identify as one of the 3 pesticides based on its retention time, and of course, retention time is present in the database. But the 2 peaks in the middle have very similar retention times and very similar mass spectra. Which one is which is not really clear. So in this case, high resolution or accurate mass cannot really differentiate these compounds successfully. However, an SMS analysis can. If you look at the broadband CID spectra for these 2 chromatography peaks, we see that the parent ions are the same. But fragments are different, and unique fragment ions are used to distinguish even isomeric compounds. Now we can extract ion chromatograms for these fragment ions and perform quantitation of each of the 2 pesticides individually. Earlier, I mentioned that different ions can be selected for quantitation to avoid interferences. So this is one of the examples. And one more example. So another pair of pesticides in a single mixture, same molecular formula and ionization behavior, and even the same elution time. So this guy is coiled. Parent ions have the same exact mass, and some of the fragments are the same as well. However, the TargetScreener database contains information on multiple broadband CID fragments. And some of them are unique for each pesticide. Thus, we can extract ion chromatograms for these unique fragments and distinguish these 2 pesticides reliably. Better yet, TASQ software interface in a data review interface highlights known interferences in a database and if any of them have been registered in the actual samples, so like this. Another very handy feature of the interface is that it allows to literally flag compounds that need special attention during the review process. But we'll get to that later. And by the way, European regulation, so-called Center 11813, states that ion chromatograms showing significant interference cannot be relied upon for identification. And that, of course, could be a problem. However, it's possible to resolve such cases by using 2 or more diagnostic ions with mass accuracy of at least 5 ppm. And TargetScreener, of course, is capable of mass accuracy of 1 ppm or lower and can do it quite easily. As I mentioned earlier, diagnostic ions, such as fragments, can also be used for quantitation. In cases of interferences, it may actually be the only option to do it reliably. For instance, if we try to quantify these 2 pesticides that we saw in the previous example, we will not be able to do it using parent ions. They have the same molecular formula, exact mass, and appear the same. However, if we use fragment ions that are unique for each of the pesticides, now we can quantify them individually, overcoming this interference. Now let's review the workflow that TargetScreener provides. It is fully integrated and automated for data acquisition and direct export of results to PDF test reports or lab information management systems. Most software packages for LC-MS were originally developed for biopharma industry, and applications are typical there. However, most other industries, such as food, environmental, or forensics, for example, may have different needs and requirements. For that reason, TASQ software from the very beginning was developed to address these specific needs and these specific applications. TASQ software is in the core of the TargetScreener solution, and it was designed to provide fast, easy to use, and efficient workflow for typical food analysis applications. So we just discussed the data acquisition and compound identification. And next, we will look into TASQ data processing in some more detail. The data processing starts with automatic calculation of exact masses for target analyzed based on their chemical formulas. And of course, chemical formulas come from the database. Then ion chromatograms are extracted for these exact masses. Then the system checks for presence of any peaks in these extracted chromatograms. And if there is more than one peak, the system checks the retention times and compares them with the database. If a match is found, the system checks for a presence of diagnostic ions listed in the database for this given compound. And finally, the identification scoring is based on 4 criteria, namely the mass accuracy, the retention time, diagnostic ions, such as fragments and ionization patterns, and isotopic patterns. Data review with TASQ software is intuitive and basically based on traffic lights and color coding. User doesn't really need to be a mass spec expert to make correct interpretation of the results. So this is what TASQ software user interface looks like. The ribbon on top, the blue one, allows to switch between different views. Right now, we're looking at the review screen. This is designed to provide screening and quantitation in one continuous workflow with actually no interruption at all. A list of queued or analyzed samples is on the top left. A list of identified analytes is on the top center. Below it is an extracted ion chromatogram and the mass spectrum for the selected analyte. And below that is a list of all diagnostic ions for the given compound with all related information. Important thing to note is that quantitation results are displayed next to the screening results for all calibrated compounds. So you don't have to go to the separate workflow to quantify what you have in a sample. TASQ software is, its user interface is very flexible and easily customizable. Its elements can be arranged in different patterns and utilize multiple displays. Flag filters is another very useful feature. They allow to bring to users' attention only compounds that require an additional review and kind of ignore everything else if you have confidence in it. In this example, a flag filter is linked to a multiple chromatogram window on a second monitor on the left. So basically, every flag compound gets its extracted chromatogram presented. The traffic light icons represented the identification confidence are linked to the detailed ion results window below, those highlighted on this left. So after very little practice, it's really possible to grasp the analysis results in a single glance. It's really a very intuitive interface. And this is a quantitation view of the TASQ user interface. Here we can see calibration table on the bottom and the calibration plot on top. On the plot, we get marks for analyte concentration in any selected sample. Important feature is calibration residual plot in the middle. According to the center regulation, it must be less than plus minus 20%. And here we can easily see that where it stands for each calibration point. Typically, TargetScreener provides 4 orders of magnitude for linear calibration range. However, it may vary from 3 to 5 orders of magnitude depending on the analyte and the matrix. TargetScreener comes with a set of pre-installed batch report templates. Different templates are available for various analysis, including screening, quantitation, and combined qual and quant. Some customization of the report templates is available to the user as well. It's important to mention that TASQ software architecture is based on the client-server principle. Multiple users can access the same server for parallel data acquisition and review. This architecture also allows to collect data from multiple instruments of different types and review results remotely outside of the lab. That, of course, is very important these days. By the way, TASQ software can run on many different Bruker instruments, including Evoque triple quads, for example, as well as Amazon Eintraps, obviously QTOF instruments, and even flagship timsTOF. In conclusion, let's review some of the key benefits of the TargetScreener workflow. Firstly, this platform collects all the data all the time, thus providing retrospective data analysis capabilities, and it is very capable in identification of unknowns for the same reason. It makes a TargetScreener perfect solution for in-depth investigative food screening and retrospective data mining. Secondly, it reduces false positives and false negatives by utilizing multiple identification criteria. It includes accurate methods, fragment times, retention times, and isotopic patterns. All this information is contained in highly curated database supplied with the instrument. And finally, it provides high confidence screening and highly sensitive quantitation in a single run and really seamless, fully integrated workflow. And that brings us to the end of this presentation. Thank you for your attention. I will take any questions.
Thank you, Dr. Filipenko. Yes, we will now take any questions that you might have. Remember, if you could just use that question box and send those along. I know I saw a couple coming through. I have one here that's sort of a multi-question for you. Can I add my own compounds to the database? Can I change the retention times or other parameters of compounds in the database if I want to use a different method?
So yes and yes. It's actually pretty easy to add new compounds. There are several different ways of doing it. So, for example, if you already have some kind of a list of target analytes that would contain molecular formulas and preferably retention time, they can be added through important and CSV files. Alternatively, it's always possible to add new compounds by just running standards. But what is also interesting, even if you do not have standards for a new compound you would like to add, you can still run them as a suspect, meaning that having information just on molecular formula of the compound is sufficient for the instrument to run and provide some data on presence of these compounds in samples, obviously with no information on retention time. So identification confidence will not be as high, but it's still possible to perform this, what we call screening for suspects, having only molecular formula to go by. Speaking of the methods, yes, methods can be changed. Obviously, the instrument is supplied with pre-developed methods. And these pre-developed methods, one for LCMS and one for GC-APCI, is really needed to make use of the database also provided with the system. They kind of work in conjunction together as one standardized solution, and that kind of makes everything click. However, if you prefer to use instrument for some other applications that do not rely on this existing database, you're totally free to use any other custom methods at your convenience.
Okay, another question here. You might have addressed this in your presentation. Can I use this system for identification of unknowns?
Yes, and actually, this system is it's really very powerful, specifically for this application. So firstly, identification of unknowns can be done retrospectively. The reason for that is, of course, that high-resolution accurate mass QTOF instrument with broadband CID acquisition allows to do it retrospectively because it collects all the data all the time. So you literally never miss anything, right? And all information about chemical composition of the sample is acquired and stored on a single run. You can always go back and look for anything that may not be present in your database at the time when you ran the sample. So it's never lost. And of course, with high resolution and accurate mass that this instrument provides, the identification process really can provide very impressive data and very high results.
Okay, here's a question. Does the database have information about ion ratios of fragments?
I don't think so, but this is something that we'll need to double check.
Okay, we can contact this, the person who asked that offline. Another question, is the client-server software standard? Is it standard, or do I need to buy separate licenses?
So the client-server software comes standard with TargetScreener as a solution. And if memory serves me right, it includes 3 floating licenses for the data review client, but don't quote me on that.
Okay. How about, is the TASQ software can be worked for Evoke GCMS? Is it CFR 21?
So it can be used with Evoke GC, yes, absolutely. About CFR 21, no.
Okay. Could you explain pros and cons of the bbCID compared to regular product ion scan?
Yes. So with a regular product ion scan, so first of all, you will need to spend instrument time, and that kind of affects the duty cycle on isolation of every ion that you would like to fragment. So this will be what's called data-dependent data acquisition. So it means that, first of all, the instrument will need to register the peaks and parent ions that it will later fragment, right? They will typically need to clear certain threshold on their intensity. Otherwise, the instrument will be fragmenting basically noise. And all of that takes a certain amount of time, which may be critical when working with really short gradients and very fast UHPLCs on the front end to, of course, increase the throughput. Broadband CID, since it doesn't do any isolation of the parent ions and fragments everything indiscriminately, it provides full information on chemical composition of the sample, regardless of any timing restraints or even if any compound doesn't necessarily clear the threshold of intensity to be flagged for fragmentation. It still be fragmented, and it can actually have positive effects on sensitivity as well. So yeah.
Okay, thank you. Another question here. What is the mass range of MS1 for bbCID?
If memory serves, it's around 8 kilodaltons, but let's check that with specification. I don't necessarily have it from the top of my head.
Okay, we can always contact the person who asked that offline as well. Another question, can I have any references of regulatory laboratory that uses APCI, GC-LC?
Sure. In Europe, there are several labs that use it, and we can provide references.
Okay, just a couple more questions here. What would be the influence of sample matrix on QTOF systems?
So the matrix effect on QTOF system would actually be very similar to effects on any other mass spec, right? Because it's dependent mostly on the matrix itself and on ionization mechanisms. What QTOF system gives you is it allows to overcome some of the possible interferences, and of course it's high resolution, accurate mass, broadband CID, and other advantages. makes it much more powerful analysis in those complicated samples. But the effects themselves are very similar.
Okay, here's some. Can we have some application notes on GC-APCI?
There is an application note on GC-APCI attached to the package that you can download from this webinar. It actually shows some very nice examples on quantitation of pesticides using GC-APCI.
Okay, I'm not sure I understand this one, but I'll read it as it's stated. Can I use any BRADD GC with the QTOF?
I'm not sure I understand the title.
Okay, well, we can always contact the person who asked offline as well. Okay, one more question here. Is bbCID the same as DIA with different MS1 windows?
So if the question about data independent acquisition, in a way, yes, but there are no windows, right? So all lines coming from the IN source are fragmented in broadband CID indiscriminately. So everything that comes from the source gets fragmented, and we get a full scan in high resolution from time of flight part of the instrument.
Okay. And last question here. Why use broadband CID for data acquisition?
So I think we already reviewed that question in some of the previous questions. So there are obviously several reasons, and we already discussed one, identification of unknowns and retrospective data analysis. These two applications are really well served with broadband CID because, again, it captures all the data all the time, all the fragments are there, so it's complete information on chemical composition of the sample, nothing is lost. But as I also mentioned, there are also some nuances about related to the thresholds or fine intensity peaks that would flag them for data-dependent acquisition and fragmentation. And also this method works better with sharp gradients and faster UHPLC. So no lost information, and sensitivity can be a little bit higher as well.
Okay. Well, we've run out of time, but if we did not answer one of your questions, we will get back to you offline. We promise. We want to thank you all for joining us this afternoon. You're going to receive a recording of this webinar within 24 hours. Please be sure to also visit us online, as we do have a series of other webinars and some also related to this topic. And we hope that everyone stays safe from the COVID-19. And thanks again, everyone, and have a wonderful afternoon. Thank you all.